Hello students, today we're going to look at section 4.5, which is scatter plots and lines of fit. And I know this is going to be a review, but there's some vocabulary that I need to make sure that you understand because you may see it somewhere and you need to know what it means. Okay, when we talk about scatter plots and lines of fit, some of the things we're going to talk about are bivariate data. Bivariate data, okay? That is data with two variables. And I put in, could be in with bivariate, the prefix bi means two. So I've got two variables, and that's x and a y. So we've been working with bivariate data for a long time. But bivariate is data in two variables for us. A scatter plot is a graph that shows the relationship between bivariate data. So on a scatter plot, I'm going to plot those bivariate data, the x's and the y's, and I'm going to show a relationship between those. Okay? The next one is a correlation or an association. You might see those interchangeably. Correlation or association. Correlation is the type of relationship between the bivariate data. The type of relationship between the bivariate data. Isn't that a fun word, bivariate? It's kind of crazy. So let's look at the three types of relationships that we could see in bivariate data. So I'm going to draw a quick x-axis and y-axis. And I might have some dots that are scattered like this. Okay? And this type of relationship would be a positive correlation. And the reason it's a positive correlation is because as the x increases, the y is increasing as well. Now it does not form a line. In scatter plots, we don't typically form a linear function. It's just scattered all over the place, but they seem to be rising. So as the x increases, the y increases as well. This could be something like, say, the number of tickets to a movie sold and the amount of profits for the movie. As the number of tickets increases, the amount of profit they earn from that movie increases. Okay? There's another type of relationship. Do my x-axis and my y-axis, and you might have data here, over here, okay? And it's scattered, but you can still kind of see a pattern going down, and this would be a negative correlation. Okay? A negative correlation means as x increases, y decreases. That could be something like the number of miles that you drive and the amount of gas in your gas tank. So the more that you drive, the less gas there is left in your tank. So we have to stop and get gas. That would be a negative correlation. Number of miles increasing, amount of gas left in your tank decreases, so that makes it a negative correlation. And the last type of correlation that we'll look at, draw an x and a y-axis. This kind of correlation is no correlation. Because the scatter plot is scattered all over the place. You can't really see if anything's increasing or decreasing. They're just all over the place. So that would be no correlation at all. So it's important that we understand the different types of correlations because that's going to be important as we keep going. So I'm going to get a different color right quick. Let's use green. So we're going to say x increases and y increases on a positive correlation. On a negative correlation, x increases and y decreases. And for no correlation, neither one. There's no correlation. We can't really tell. So that's the important data as the definitions, and we'll look at some real scatter plots in just a second. So first of all, you do not have to draw this, okay? You don't have to draw this. If you want to write the table, you can write the table, but I'm not expecting you to draw this graph. You don't have to. Just listen, because I know you can get it. I didn't mean to spin like you're crazy. I know you can get it. You don't have to draw it. This is a table. There's a zebra mussel issue in Texas, especially. There's even one in Lake Waco. We have too many zebra mussels, and they take over the entire lake, and they cause problems. So the state of Texas tracks those puppies, and it's not a good thing because they grow really fast and they cause problems. So the year since 2009, and the number of zebra mussels in thousands. In 2010, we had 15,000. In 2011, 125,000, and you see how it increases. Remember, this is year since 2009. So that would be 2010, 11, 12, 13, 14, 15, 16, and such. Okay? So I graphed it. You don't have to. You can if you want to, but you don't have to. I graphed it, and you notice that this is not linear. I can't draw a straight line to get through all of those points. That's impossible. And that's good. It's a scatter plot. We don't want a straight line to connect all of the points. But what we do need to do is draw a line of best fit. That line of fit is going to go through the middle of those points. It may, and usually does not, include any of the points on the line. Okay? So we're going to try to place our ruler between the points so that about as many of the points are on top of the line as they are below the line. So we're just going to try to eyeball it. Now, nobody's going to draw the same line of best fit. It just doesn't happen. Okay? When we use our calculators later on, it'll give us a better idea based on the data. But right now, we're just going to try to draw a line of best fit. And so I just put my ruler here, and try to get as many. It's kind of hard to see since this ruler's so fat. As many below as there are above. So I'm going to draw it right here. And I have a few below and a few above, and so that would be a good line of best fit. Okay? Why do I need a line of best fit? That line of best fit helps us to make predictions. Okay? So if I needed to know about how many zebra mussels are going to be in the year 2025, that's 16 years after 2009, so I'd have to go over 16 and keep going on my table. Or I could use the equation of this line of best fit and figure out, now how do I find the equation of the line of best fit? Ding, 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 ding. That's the important question. To find the equation of the line of best fit, I'm not going to do it right here. You would look on your graph because you're going to have graph paper and you're going to have a better, an easier deal with finding. And you would find 2 points on the line. Okay? So right now, I don't have any points that are directly on the line. I have this point that's close, and I have this point that's close. So I could use those 2 points. So you got to make sure they're really, really close to the line now. So on this one, this is point 2, 125. And then this one is point 1, 2, 3, 4, 5, 325. So I need to know the equation of the line. I have 2 points, so I've got to find the slope and then give an equation of the line. So the slope is y2 minus y1 over x2 minus x1. So I've got 325 minus 125 equals 200 over 5 minus 2 is 3. So my slope is 200 over 3. If I went too fast, I just did y2 minus y1 over x2 minus x1. I got 200 over 3 as my slope. Okay, now I need to know my y-intercept. So I'm going to use 2 and 125. So 125 equals 200 over 3 times 2 plus b. Yes, we get into some crazy numbers here because it's a scatter plot. That's why we have calculators. So I have 125 equals 400 over 3 plus b. I know that 125 is 375 over 3 equals 400 over 3 plus b. And now I move 400 over 3 to the other side, and I subtract those two, and I get negative 25 over 3 equals b. I have my slope, I have my y-intercept. There's my equation. Y equals 200 over 3x minus 25 over 3. And you may or may not be able to see that. Oh, there it is. And that is the equation of the line of best fit that goes through my scatter plot. Okay, that's nothing new. It's taking 2 points on the line. You just have to figure out what those 2 points are. Plugging in, finding b, finding your slope, and then writing the equation of the line. Now, if I wanted to know how many zebra mussels are predicted in the year 2025, that's 16 years after 2009, so I'd plug 16 in for x, use my calculator to calculate that, and then I could find exactly how many mussels are predicted. Okay? That's what you're going to be doing with scatter plots, is estimating data based on what we already know. We collected some data when we threw those ping pong balls and the cheese balls, and so we're going to use that data that we already graphed, I think today maybe. We're going to use that data with some more scatter plot things in class, so make sure you have that with you. What I'd like for you to do now is just take a picture of your notes and submit it through Edmodo because there's no practice problem. Merry Christmas.